Pixotope Academy. Today we'll be discussing compositing with AR using Pixotope 2.0. This tutorial will provide an overview of the most common techniques for AR, including shadow, light, and reflection catchers, video holdouts, and translucent materials. Here you can see our completed AR scene. But first, let's discuss what makes up an AR scene. This is where digital objects are overlaid on top of real-world elements. Through camera tracking, we're able to not only overlay the graphics on top of the video plate, but we can also anchor these elements into the real world so that they're spatially aware. This way, they can react appropriately to any camera movements as if they were in the actual real-world environment. If you look at the clean plate to the right-hand side, you can see what real-world elements make up our physical set. We have some cardboard boxes, a reflective board, a wooden wall, a banner on the right-hand side, and practical lighting coming from two off-camera light sources on the set. And on the left-hand side, we can see the digital elements that we have overlaid on top of the video plate. We have our virtual robot named Dot. Next to them is an award statue, and there's 3 translucent spheres resting on top of the cardboard in the foreground, as well as a digital lamp casting light across the back wall. So for a scene like this, what do we need in order to properly integrate the digital objects with the real-world elements in our video plate? First, we're going to need to create visual geometry replicating the real-world environment so that it can properly catch shadows, reflections, and lighting. This is accomplished by using standard geometry with a basic shade material, which is then positioned, scaled, and oriented in order to match the real-life elements as best as we can. You can see we have 3 light sources. The light on the far right and left are meant to emulate the actual light sources that we have on set, so we've dialed them in to reflect the intensity, direction, and color temperature of the real-world lighting as best as we can. We also have a third light that is emulating the light that would come from our digital lamp to the left of the robot. We've modeled some basic geometry to mirror the floor and wall layout of our sets, as well as the cardboard boxes and reflective surface behind the robot. And we've also have 3 translucent spheres on top of the cardboard box in our foreground. Let's go ahead and start with the foreground cardboard box, which needs to act as a video holdout to obscure Dot's legs, as well as catch the shadows of the translucent spheres. Once you've properly positioned the cube, you right-click the object and select Convert to Shadow and Reflection Catcher, which will automatically convert it to a video holdout as well, allowing it to catch the shadows of the translucent spheres on top of it. And now we're going to apply this same process to the wall and the floor, which has been modeled to fit the set. Under World Settings, you can select AR VCVig in Editor, which will allow you to see the background plate while you're working in Editor. This can help you to orient and align your CG elements with the real-world ones they're emulating. And in regards to the spheres, these are just standard spheres with a translucent material applied to it. They're being converted to a translucent object, which means that it's a material which has refraction. To illustrate this, we'll copy a sphere, and now we're going to scale it up so you can see it visually warp the view of the backplate behind it. And now we can see the shadows of the robot, as well as the digital lamp, statue, and the spheres, all casting on top of the real-world elements. Additionally, we have the light of the lamp reading across the wall. All of this is helping to better sell the illusion that the digital elements are in the same physical space as the real-world ones. In Pixotope 2.0, we have a new light catcher feature under World Settings. When selected, this will transform every object that's been converted into a shadow and reflection catcher to also be a light catcher. For example, we can see this when we adjust the color and intensity of the point light, which is being used as a light source for the virtual lamp. This can help you to dial in the virtual lights to better integrate with the real light sources being used on set. And now that we've set up the shadow and light catchers, as well as the video holdouts, we're going to now set up the reflection catcher. For that, we're going to use another plane, which is being placed as best as possible to match the reflective object on set. As you can see, this is reflecting not just the robot, but also the set itself. That's because we have a skylight in our scene, which is using a 360 HDR panorama capture from our set. If we open the texture, you can see what the panorama looks like. This was captured using a Theta 360 camera with multiple exposures from the same location, which we then mapped to a sphere. Then we've taken all these other geometries and AR meshes and excluded those from being captured in ray tracing in order to blur out the reflections, since we're using ray traced reflections. Now that our scene is properly constructed, we can do a bit of fine-tuning using Director. Let's open Director, and under the Production view, we'll go into the Compositing tab. Here, we can adjust the shadows using the global intensity slider. And we can also affect the ambient occlusion, which you can see directly impacting the shadows under the translucent spheres. Now under reflections, we can adjust the strength and transparency sliders, which you can see affecting the reflective material and thus the reflection of the robot. With the values maxed out, we have a pure AR reflection. And as we pull the transparency slider back towards 0, we have a much more subtle and better integrated reflection for the material in the scene. And with that, we're done prepping our new AR scene. Thank you for joining us for this Pixotope tutorial, and please see our library for more resources to get the most out of your next production with Pixotope.